Okay, this section is on exponential growth and decay. What you want to pay attention to so that you know when you have one of these types of problems is this part right here in the quote. So you can pause and read this whole paragraph, but what I'm going to emphasize is this. The rate of change of the amount of a quantity equals some constant times the amount present at any time t. It might also say something like the rate of change of an amount is proportional to the amount present. All right, so let's take that and let's write it in some calculus notation. So I'm going to write this, and this is under the block in the actual flip chart. So a rate of change, how do you write a rate of change? Yes, d something dt. Now, we're saying the amount of a quantity that's present. So the original equation was going to be a y equals something, so y is your amount. So the rate of change of y with respect to time is dy dt. And then it's proportional to something. And again, if you see right here, it says this constant is usually going to be k, lowercase k. That's called your constant of proportionality. So I'm going to write k, that's the proportional to the amount present. Okay, so now what do we have? We have a differential equation, and we can solve the differential equation. You just did a bunch of those in the last section. So let's separate things and get the y with the dy. And we can take the k with it, or we can just leave the k on the right-hand side when we bring the dt up. So that's what I'm going to choose to do. So if you integrate both sides and move the dt, we're going to have the integral of dy over y equals the integral of k dt. So all I did was multiply both sides by dt, divide both sides by y. Okay, now solve your equation, and you get ln natural log of the absolute value of y equals k times some variable, right? This is telling you the variable. So kt plus c. Exponentiate both sides to solve. So I'm going to take e to both sides. And now I'm left with the absolute value of y, which I'm not going to write the absolute value, and I'll explain that in a minute. And then remember what we did, again, in the last section, to simplify something like this. This is e to a sum, so it breaks up into e to the kt times e to the c. And the e to the c is just a different c. And this is our exponential growth function. Okay, make sure you have this written down, and also make sure that you know what all the parts are. Okay, so your y is going to be your amount of your substance at time t, so that takes care of what that variable is and what that variable is. Now, c, if you think about putting in a 0 for time, then e to the 0 is 1, so y equals c. So at time 0, or your initial time, y equals c. So c is your initial amount. And then k is your constant of proportionality. If k is positive, you're going to have an exponential growth function. If k is negative, you're going to have an exponential decay function. Okay, for this example, you're given a chemical. Bismuth 210 has a half-life of 5 days. So as soon as you see half-lives, that's going to be an exponential decay problem. And if you just always remember that as soon as you see an exponential decay problem, we're going to use y equals c e to the kt. If you just come up with a couple of points, then you'll be able to solve for your two variables that you're going to want to solve for, which are your initial amount and your constant of proportionality. Then you'll end up with a function that is y equals a function of t. So you can answer any kind of questions. You can answer how much you have after 30 days, and then you can also answer questions the other way, like this one, when is the mass reduced to 1 gram or milligram. Okay, so let's start with trying to figure out what kind of points we can use or what we can fill in. This says a sample originally has a mass of 800 milligrams. So already we don't even have to solve for C. C is 800 milligrams. I'm not going to put the units because when I put it in the equation it will look like a variable. Find a formula for the mass remaining after T days. Well, if your original amount is 800 and you have a half-life of 5 days, think about a point that we could come up with. Now, since normal points are x, y, where y is a function of x, then this is going to be ty. Our points are going to be ty. So what is our time? Our time is 5 days. After one half-life, if you started with 800, you have how much? Okay, good. Hopefully you said 400. All right, so that's one of our points. So let's use the equation y equals ce to the kt, but fill in, I already wrote the y, so we'll do this. We're going to use 800 for C. And now we're going to, maybe I'll use a different color, throw in this point. So 400 equals 800, that's my C, e to the kt. T is going to be 5, but we don't know our k. Alright, so now we have an equation we can solve, right? We can solve for k here. So what would you do first? Pause it and think about it if you want, because you guys could solve this equation. This is definitely pre-calc stuff. Okay, so once you get rid of that coefficient, then you can natural log both sides, because there's nothing in your way, and then you have 5k equals the natural log of a half. Divide both sides by 5, and you have your k. And again, because this is a half-life problem, you should be getting a negative number here. I'm going to pause, use my calculator, and get a decimal accurate to 4 significant figure. Okay, so once you solve for your k, put it back into your equation. Y equals, substitute in your c, e to the, now substitute in your k, 1,386 t. So that is writing the formula for the mass remaining after t days. Okay, now for part B, find the mass remaining after 30 days. 30 is your time. Time is the variable t, so just put 30 in for t and get your answer. So pause this. I'm going to use my calculator and pause as well and come up with the answer. Okay, try not to round too early, because you know what Mr. Conka says, if you round too early,
people die.
All right, Alec. All right, so you get for this answer 12.5, and now go ahead and label it milligrams. Before I get the next answer, think about the fact that with this particular problem, you probably could have done this in your head, right? You're starting out with 800 milligrams. The half-life is every 50 days, and because 30 is a multiple of, I don't know what I just said, but I should have said 5 days. Because 30 is a multiple of 5, you could just keep having this, right? So if you started to take half of that, how many times would that be? So 5 days, then 10, 15, 20, 25, 30. So you'd have 800 milligrams, then 400 would be after 5 days. And then after 10 days, you'd have 200. After 15 days, you would have 100. After 20 days, you'd have 50. After 25 days, you would have 25. And then after 30 days, you'd have 12 and a half. All right. Okay, for part C, when is the mass reduced to 1 milligram? Now 1 this time is not your time, right? 1 is your amount. So now we're going to use, oops, forgot to make it the pen. Now we're going to use the amount variable, which is y, and set that equal to 800 e to the negative 0.1386t, and solve for t, and that's going to tell you your time. So think about the steps, pause if you want to try it yourself first. Okay, so it's going to be similar to when we solved for k. So then we're going to natural log both sides. So I'm going to have the natural log of 1 over 800 is negative, and it helps if you store this. A long time ago when you solve for k, if you store this quantity into something like a, then right now I wouldn't be rounding. I'm actually going to make sure whenever I put this into my calculator that I get this answer again, because I forgot to store it in a. But I'm going to actually calculate the negative 0.1386 again, but completely accurately. And then I'm going to take the natural log of 1 over 800 and I'm going to divide by it. So I'm going to pause, you can pause, and go ahead and get your answer. Okay, so before I write the answer, I want to point out one more thing that you can kind of ballpark your answer. We got to 30 days was 12 and a half. So to get down to 1, if we take half of 12 and a half, we're going to get 6 1/4. If we take half of that, we're going to get 3.125. If we take half of that, we're going to get 1.5 something. So to get down to 1, it's going to be a little more than 3 more half-lives. So it'll be, what, 35, 40, 45. It'll be a little bit more than 45 if you wanted to estimate your answer before you got it. And I already did get it on my calculator. Let me pick a better color because everything's getting jumbled. Okay, so the answer to part C is 48.2. We'll just round to the tenths place. 0.2 days. Okay, and then sketch the graph of the mass function. That's easy enough. Just graph this on your calculator. Because it's an exponential decay, because it starts at 800, you actually should know that it's going to look something like this. And we'll pretend that crossed at 800. Okay? Alright, next problem will be in another video.